Assalamualaikum and salam sejahtera. In this video, we will discuss the techniques of differentiation. Okay, so for the techniques of differentiation, we have discussed the product rule. Okay, so now in this video, we want to discuss the quotient rule. Okay, sorry. Okay. What is the quotient rule? Okay. So in this slide, we look at this slide. Okay, product rule for the product of two functions. Okay, you can check my previous video about the how to differentiate the product of two functions using product rule. Okay, the second one is the quotient rule. Quotient rule is used to differentiate the quotient of two functions. Okay, the difference with the product rule is the product rule is for the product of two functions, multiplication of two functions. But the quotient rule is the quotient of two functions. Okay, that is the division of two functions to any two function. Therefore, the formula for the quotient rule is given by dy over dx equal u prime v minus uv prime divided by v squared. Okay, unlike the product rule, so for the product rule, the formula should be no problem if you write the different formula. Okay, because of the plus sign here, not the positive, the plus, because of the plus of the two formula. However, for the quotient formula, please be careful. Okay, you need to write in the correct sequence because of the minus sign here. Okay, so we will look at the example of the quotient rule. So for the quotient rule, there are several examples for the quotient rule. Okay, so the first one is the quite basic example. Okay, if we look at this example, we have the quotient of two functions. The first function is at the numerator, the second function is at the denominator. Okay, so just like the product rule, we name the numerator as u, the denominator as v. Okay, for the product rule, dy over dx or any function dy over df over dx or dg over dw. Okay, anything. But dy over dx equal u prime v minus uv prime divided by v squared. Or I think some of you write this as vu prime, okay, divided by v prime u. I think something like this. I can't remember. Okay, divided by v squared. Okay, no matter how you write, but please be careful because of the minus sign here. So if we want to use the product rule, so g prime w equal u prime v minus uv prime divided by v squared. Okay, so here what is our u? Our u is w cube minus w, and v is exponent w. Okay, so u prime here is du over dw. It depends on the variable of the function. So u prime is 3w squared minus 1. So v prime is also exponent w. Then substitute into the quotient rule. U prime is 3w squared minus 1, okay, times v is exponent w, minus uv prime, so our u now is w cubed, minus w, v prime is exponent w, divided by v squared, okay, exponent w power of 2. You can leave your answer here, okay, or if you want to simplify this function, perhaps you can factor out the exponent w, okay, times 3w squared minus, if we want to simplify, if not, just leave your answer there. Because what important is the formula and the differentiation of each function. So 3w squared minus 1 minus, please once again, please be careful with this negative sign, with this minus sign, negative w squared w cubed plus w, okay. That's why sometimes I don't it's not difficult actually, but I don't suggest you to simplify the function because of this small mistake, okay. Exponent w, eliminate, so if I rearrange the polynomial from the uh, higher from the highest degree up to the from the highest degree, so negative w squared plus 3 w squared and negative w cubed plus 3w squared plus w minus 1 divided by exponent w. This is also the final answer. It's up to you, okay. Okay, sometimes some of the students didn't like the formula of the quotient rule, okay, but what they have done is, okay, I will write the alternative here. However, if the question if the you have to read the question carefully. If the question want you to use the quotient, so please use the quotient, because we want to look at how you apply this formula, the quotient formula. But in the reality, okay, not in the exam, so you can use the suitable function up to what formula that for you, that because each individual has their own preference, okay. So if you prefer the formula, the product rule formula, so you can use the product rule, okay. If you don't mind about the quotient rule formula, so you can use the quotient rule, okay. What I want to say that for this question, okay, so we can also change to this kind of function. We bring to the exponent to the numerator, okay. So exponent, because we bring to the numerator, so exponent w becomes exponent negative w, okay. This one is the product rule. You can use the product rule. Why? Because of the function, the product of two functions. So we can use the product rule, okay. Okay, how? So g prime w now is u prime v plus u v prime. So you can write the what's u. This one is u. U is w square. W U, okay, W V is exponent negative W. If we substitute U prime and also V prime into the formula, so we will get 3W square. Okay, 3W squared minus 1 U prime V. So V is exponent negative W plus here is U. U is W cubed minus W. V prime is negative. So because of negative, be careful about the negative. So negative exponent negative W. Okay. So you can leave your answer here, or you can change back the exponent negative W to the numerator. So you can rewrite 3W squared. Okay, minus 1 divided by okay, because this is just the same apa ni, the same term exponent W, so I will combine it. Negative W cube minus W divided by exponent W. Okay, so if we look, the answer is similar with this, right? Okay, all right. Okay, for the example B. Okay, example B also quotient function, quotient of two functions, so U and V. So if we use U is x cube. I think you can do this by your own. Let me show you. Okay, I think you can do this by your own, so I don't need to explain this. Okay, so I will just give you the answer. So you define by your own what is U, what is V, then find the U prime and the V prime. Okay, so the final answer is 3x squared minus 12x. Okay, times x plus 1 minus x cubed minus 6x squared plus 8 times 1. So I don't want to write the 1, so divide by V squared. So x plus 1 squared. Okay, so you can just leave your answer up to this. Okay, or you can simplify whether you can expand, okay, this function, or you can separate these two terms. Okay, so the first one you can eliminate with the x plus 1. The next one is just divide by x plus 1 squared. Okay, it's up to you. Okay, try that question by your own. Okay, I want to explain the next example. So for the next example, so same as the previous. So we have the quotient of the function U and V. Then our U is different. Just define our U as squared plus exponent 3x. Okay, V is 1 plus sine x. Okay, U prime now is 2x. Okay, now we have the exponent 3x. Okay, remember that the differentiation of exponent x is exponent x. However, if we have the power of other than x, so what we can do is just the same as we differentiate the tangent 3x. So we have here is exponent 3x. So just differentiate as exponent 3x. However, we need to multiply with the differentiation of the power. Okay, so differentiation of the power is 3. Okay, like that. So V prime is 1, differentiation of 1 is 0, differentiation of sine x is cos x. Okay, substitute into the formula of the quotient rule. What is the formula? U prime v minus u v prime divided by v squared. Okay, so u prime is 2x plus 3 exponent 3x. Okay, v is 1 plus sine 2x. And not sine 2x, sine x. Sine x minus u is x squared plus exponent 3x. V prime is cos x. Divided by v squared. V squared is 1 plus sine x power of 2. Okay, so same as the previous example, just leave your answer here. Okay, after you substitute into the formula, then leave. Unless, okay, if the question instruct you to simplify your answer, or the question that need you to show for the particular answer. Okay, then you need to simplify. If not, just leave after you substitute the function and the differentiation into the formula. Okay, the last one is this one you can I will show this. Okay, I will show this because okay, for this one is the combination of the differentiation without the quotient rule. Okay, this one is without the quotient rule. However, for the second term, we need to do the quotient rule. Okay, so this one is our f prime. So f prime x equal, okay, the differentiation of ln x is 1 over x. So for the ln 2x, also the 1 over 2x. Okay, but same as the exponent, same as the trigo, once we have another expression other than x, so we need to multiply with the differentiation of the expression. Okay, so for example, in this example, differentiate 2x is 2. Okay, minus, okay, the second one, we need to use the quotient rule. U prime v minus u v prime divided by v squared. Okay, define for the u and v. So our u now is exponent 3x. Okay, so our v now is 2 exponent x. So u prime is 3 exponent 3x. I already explained about the differentiation of exponent 3x. But for the v prime, be careful, this is not 2x. Okay, if you look at my slide, okay, about the differentiation of the basic differentiation. So look at the a power of x. Okay, a power of x, the differentiation of is ln a times ax, or we can write this v prime. Okay, we can write this as 2 power of x ln 2. Okay, macam tu. So substitute into the example, so we can eliminate 2. The first one is 1 over x minus u prime is 3 exponent 3x times v 2 exponent x minus u exponent 3x v prime is 2x ln 2 divided by v squared 2x 2x power of 2. Okay, you can leave your answer here, or actually for this example, okay, for this example, but I think for this example, okay, we can simplify like this. 1 over x minus, because we have the exponent x and 2 power of x for both terms. Okay, so I will factor out the exponent 3x and also 2 exponent. But for 2 power of x, we can eliminate with the denominator. So the final answer should be 3 minus ln x. Ln 2 divided by 2 power of x. Okay, you try to find this answer. If not, just leave this here. So I want to discuss about the example 4. Okay, example number 4. Example number 4 also the quotient rule. Okay, you can try using the product rule. But be careful because the denominator will be x plus 3 power of negative 1. Okay, so you need to differentiate the bracket first. But I just want to show about the product rule, the quotient rule. So UB. Okay, so now we have the dy over dx, x equal 1. Okay, so this one is y prime. So what is dy over dx? Okay, dy over dx is u prime v minus u v prime divided by v squared. Okay, so our u now is 2 x minus 1. V is x plus 3. U prime is 2. V prime is 1. Okay, so when we substitute into the differentiation, the formula, so we have u prime v, so 2 x plus 3, okay, minus uv prime. So 2v prime is 1, so just 2x minus 1 divided by v squared. So v squared is x plus 3 squared. Okay, we need to find the differentiation at this particular point. Now our point is 1, so we just substitute 1 into the dy over dx, so into your answer lah. So when we substitute 1, we have this one is berapa? 8 minus 2 minus 1. 2 minus 1 is 1, divided by 4 squared. Okay, berapa tu? Okay, 7 over 16. Okay, like that. Okay, so this is the last example for the quotient rule. So I will stop here. So thank you for your attention.